Okay, so for two terms, still going to kind of back up a little bit for this one because you've got two options it could be. Option one, you're going to look for greatest common factor. Okay, if you have it, that's great. If you don't, then the second option is you're going to do the perfect squares. If it's neither one of these two, then it still could be prime. Now, prime is not like the drink, no. Just prime meaning that, it won't factor when we go through these things. Okay, so what we're going to do is we're going to do a couple of them where we're just doing GCF. And again, we've kind of already done that a little bit. We're going to do just a few more of those just to make sure we got it. And then we'll show you how to do the perfect squares one after that. So. All right, so kind of backing up to like we were working with the other day on Monday. So again, two terms. We're looking for a greatest common factor first. So we've got 2x to the third and 6x squared. Figuring out what your GCF would be. I'm okay that would be a 2. And we said you always take the smaller amount of x's. So we got x to the third, x to the second. So we'll take out x squared. Okay, so taking 2x to the third, and then we're going to divide it by our GCF we got here. So we're dividing that by 2x squared. The 2's will cancel. Gives us 1. We've got 2 x's we're taking out, so we'll have 1x left over on the inside. And on the second one, same thing. 6 divided by 2 is 3. When you take out both of the x's, there's nothing left over, so then that would just be what we're looking for there. Okay, so that's what we're doing Monday. Just finding GCF. Doing what we need to do, nothing really big on that one. Here's the one thing we're going to add in today. All right, let's say you get one like this, where if we look for greatest common factor, you got x squared and 49. There's not a greatest common factor, so scratch that off the list. It's gone. We're going to do a difference of perfect squares. Okay, now, here's what makes this one a perfect square. It'd be okay if you do 49, but that would be 7 times 7. Okay, x squared would be x times x. So when you're looking for perfect squares, you're looking for numbers that are, and again, if you take the square root of 49, you get the same number twice on this thing. That basically, if you get this part where as long as it's the difference between these two numbers, there's a shortcut for this thing. Since x is first, you're going to put x first in both parentheses. Since the 49 is second, we're going to put the 7 second. And then the only way to get a negative 49 is that one of these is going to be positive and one of those is going to be negative. And somebody's always thinking, all right, what do we do after that? That's it. That's all you do. And everybody's like, it can't be that easy. Yeah. So it'll be just that easy. All right, I'll show you a couple more of those just to make sure you got it. Let's do y squared minus 100. Okay, again, you always look for greatest common factor first. Y squared and 100, there's not a greatest common factor. But if you think about 100, that's 10 times 10. Y squared would be y times y. So as long as this is some number times itself, and if it's y squared or x squared, whatever, it's always going to be some number by itself, then basically you've got a shortcut. One of them's going to be y plus 10. The other one will be y minus 10. All right, let's throw a couple more at you. Let's do b squared minus 36. All right, so again, you're looking for a greatest common factor. Doesn't have anything because this one's got just b squared. This one's 36. So there's no letters, no numbers they have in common. So again, b squared is b times b. 36 is 6 times 6. And again, if you get to one number and you're not sure if it's a different number, you're not sure what it is, just kind of look at it and see. If you need to check it, all you have to do on your calculator is if you want to check to see if it's a perfect square root, just hit second and then your square root button. Oh, hang on. Hit your second and then your x squared button is right here, which will give you the square root. And then you just put in that number. So if you've got 36, there you go, it tells you it's 6. So if it's a perfect square root, if it's one of these perfect square numbers, all you got to do is take the number you have, hit second, and then square root it. As long as it comes out to be that, it's good to go. If it's some other number, if you do that and it's, let's say it's 120. Oh, hang on. If you square root it and it's not a perfect square root number, if you get some decimal number like that, it's not a perfect square, so you don't get to use the shortcut. Okay, so for this one, we'll do a b minus 6 and then a b plus 6. Okay. And it doesn't matter which one's first, whether you put the minus first or the plus first, as long as you've got a b plus and a b minus, then that's all you got to have. Let's do this. Let's do 4t squared minus 81. This one's just a little bit different. Okay. You do have 4 and 81. Now, they don't have a common factor because we can take 4 and make it 2 times 2. 81, there's nothing you can divide by 2, so they don't have a greatest common factor. So 81 would be 9 times 9. 4t squared would be 2t times 2t. Because if you do 4, it's 2 times 2. So we kind of throw that one in there. Okay, so whatever's first goes first in the parentheses. So put a 2t there and a 2t there. Whatever is the second number, it goes second in both parentheses. And then again, one needs to be a plus, one needs to be a minus. Okay, now here's as hard a one that you can get for 2 terms. So it's 2x squared minus 50. Okay. And again, always looking for a GCF first. So on this one, if we look for the GCF first, we got one, right? Because we got 2 and 50, we can divide them both by 2. Okay, and even if you missed it on the first part of it, let's say you're doing this and you didn't realize the 2 was there. If you take the 50 and try to break it down, if you do the square root of 50, you're going to see that you get a decimal number. So then that one should, get there, out of the glare. There we go. So if you check that last number, you're like, oh, that's not a perfect square. Then if it's not a perfect square, the only option then is it's got to be a greatest common factor. So then we can divide the 2 out. Once you divide the 2 out, hopefully you kind of notice now, all right, well, I've got 25, which would be 5 times 5. I've got x squared, which would be x times x. So then, if that 2 wasn't out front, we could do this part as x plus 5. X minus 5. But because we took the 2 and factored it out front of the parentheses, same thing, just leave this 2 outside the parentheses there. Okay, and that's, if we're doing 2 terms, that's about as hard a problem as it can be. All right, now, let me show you one trick question, because I only show you one, and this will be the last one of the day. because this may pop up, and I don't want anybody to get lost in this one and get mad at me because you're going to be like, you said the answer. Okay, so here's one where you do happen to pop in a trick question. Okay, because we do have x times x, we do have 4 times 4. But notice this one's a plus. Every other single one of these was a minus. It's always got to be a difference of perfect squares. So if this one happens to be a sum of perfect squares, so if you've got perfect squares, because again, that'd be 4 times 4, this would be x times x. But if it's a sum, it doesn't factor. So that one we just put to this prime. And somebody's asking, well, maybe saying, well, why would that not work? Why couldn't we just make both of them pluses? If it's positive, why couldn't it just be x plus 4 and x plus 4? Well, let me show you. And I can't remember if we talked about this part yet, because a lot of times that's the thing people want to try to do. They go, oh, I'll just make them both positive. It's x plus 4 and it's x plus 4. But remember, if you do that, you've got to do the full method. So yeah, you would do x times x to get x squared. You'd also do 4 times 4 to get 16. But remember, you also have to do x times 4 and then 4 times x. So you'd also have another 4x here and then another 4x here. Make that an 8x in the middle. So you have that. Okay, so if you're doing 2 terms and it's perfect squares, but it's a plus in the middle, it's basically a trick question. That for that part of it, that would be prime when you're doing this.